Welcome to our Federated Learning Masterclass, where we will talk about overcoming data security and privacy challenges with Federated Learning. It is widely accepted that data sharing is a barrier to applying machine learning and AI. Federated Learning is a mechanism to overcome that barrier and to build AI solutions without sharing sensitive data. It enables valuable collaboration between companies facing similar problems while mitigating the inherent risks around data sharing. Given the increasing scale of machine learning trends around edge computing and greater concerns about data protection and privacy, this technology is particularly crucial in achieving critical mass for machine learning adoption in use cases where sharing data across multiple stakeholders is necessary, unlocking insights from siloed data and adhering to an individual firm's own security measures. Today, we will spend our time discussing non-federated learning and the limitation of centralized machine learning, a couple of use cases, and we will do a deep dive on the library and why we built it. But before we move on, let's go over a bit of housekeeping. Please note the session is recorded, so if you happen to drop out for any reason or you need to leave for any reason, we will share the recording afterwards. Throughout the webinar, your camera will be switched off and your microphone will be set to mute. This is to avoid any distractions for our speakers. There will be an opportunity to ask our speakers and Nathan, our demo provider, some questions. So do submit your questions throughout the presentation using the QA box, which you should see in your menu. Make sure you upvote the questions you would like to be answered in the Q&A. The top to upvote, you just need to click on the thumbs up button. Next. In terms of the agenda for today, we'll be going over welcome and introductions, a brief intro to Digital Catapult and AI at Digital Catapult. We'll then spend the chunk of the time doing the demo and walking through the demo, followed by a Q&A. We will do panel introductions, and there will be a moderated panel discussion at the end before we wrap up and close. In terms of speakers, so we'll start off with the panelists first. So today we are joined by three panelists: Sid Kalita, the Data Innovation Lead at the Food Standards Agency; Naman Tammuz, Chief Product Officer at BitFount; Jonathan Pombach, Director, Decentralized AI Consensus Health, and he's also a research associate at Imperial College London. And I'm Simone Larson from Digital Catapult. And as I mentioned at the last slide, I will be joined by my esteemed colleague, Nathan Colson, who will introduce himself later on. So a bit about the Catapult. Our 5-year goal, in summary, is to lead technology adoption within our targeted industries, and I'll come on to that later, and accelerate the responsible and sustainable adoption of AI. For our position in the market, we work with a range of organizations such as startups and scale-ups, established businesses, investors, government, public sector, research, and academia. We work with them to discover new ways of solving industry challenges, new ways to increase productivity, and to open up new markets. Since our launch in 2013, companies that have worked with us have attracted over £4 billion in investment funding. We have also collaborated with over 50 international partners and facilitated over 1,000 meaningful engagements with industry. So what do we do? How do we do it? We build and operate physical and digital facilities for experimentation, testing, and demonstration that would not be possible without our intervention. We deliver specialized innovation and acceleration programs that foster collaboration, create opportunities, and attract investment by connecting innovative technology companies with the demand from industry. We convene and collaborate on research and development to address sector-wide problems. We pilot and build proof of concepts and showcase demonstrator projects that lead to the opening up of new markets, better ways of doing business, and growing the UK economy, which is why we fundamentally exist. Our activities are framed around 4 technology areas. It's not just AI. And these areas focus on converging to form an advanced digital technology stack. So we have immersive, virtual, and augmented reality, Future networks, which comprises of 5G, IoT, and other next generation network technologies, AI and machine learning, and distributed technologies. Our stack is constantly evolving, with new technologies such as quantum computing being added. From an industry perspective, we focus on creative and manufacturing. For creative, we are the only innovation organization in the UK with a specific remit for the creative industries on behalf of the UK government. We work with a range of partners, including Arts Council England, DCMS, and the Creative Industries Council, where we are the leading body on developing an entire new market, new audiences, and new ways of producing new content for the creative industry. For manufacturing, we focus on aerospace and aviation, food and drink, as well as supply chain and logistic opportunities. We connect manufacturing businesses with the UK innovation community to increase productivity and solve systemic industry-wide challenges. Most recently, we have launched the Made Smarter Technology Accelerator, which aims to help manufacturers solve problems that are industry-wide. We have a number of regional centers and partnerships across the UK to drive economic growth outside of London. Each center has a specific focus that responds to the need of the local market. This has resulted in manufacturing in the north of England, immersive in Northern Ireland, and 5G in the creative industries in London and Brighton. Our growing multi-stakeholder network of digital and physical facilities and clusters is aimed at driving local technology innovation, empowering local stakeholders to reach national and international markets and resources, and ensuring that the innovation community and industry have access to resources that they need. If you'd like to know more about our facilities, our areas of focus, or our industries, please do get in touch. And at the end of the presentation, we'll have contact details up. Also, please continue to post your questions and upvote questions. Let's touch briefly on the AI program at Digital Catapult, and then we'll transition to the demo, because I know that's the primary reason you have joined our masterclass. From an AI program perspective, we have 3 core areas of focus. So we work with industry, and we work with funding bodies on collaborative research and development projects. We have an MI Garage Accelerator program, and we have a growing track record in AI ethics. For industry, we work with businesses at various stages of the AI adoption journey to help innovate, test, and develop algorithmic proof of concepts. Our industry clients are able to connect with leading startups and scale-ups from the AI and ML ecosystem, as well as benefit from technology business expertise on a range of AI-related topics. Smarter is something that we've recently won via the Industrial Strategy Challenge Fund. And the remit there is to build a 4-dimensional digital twin on the combined air traffic and unmanned airspace using machine learning and deep reinforcement learning. For the Machine Intelligence Garage, this program is designed for startups and delivered in partnerships with AWS, NVIDIA, Google Cloud Compute. And the Machine Intelligence Garage helps startups that have a well-defined business problem and technical capability who are hindered by access to computation power. In terms of AI ethics, our work is very much taking ethics from theory to practical application. And we do this in a variety of formats. So we do this as a part of the MI Garage program. We have an AI industry working group. And what we're really doing are tasks that are advancing the application, the practical application of ethics. In terms of our team, so these are our core members. We have a combined 20 years of experience in applying AI to new use cases. And we maintain a variety of skills in the AI team. We specialize in predictive modeling, reinforcement learning, machine vision, edge computing, and generative adversarial networks. Again, if you would like to know more about AI Digital Catapult, we'll put up our contact information at the end. Or if you'd like to learn more about the Catapult as well and how to collaborate, do reach out and let's stay in touch. I will now transition to Nathan, who will step through the demo.
Hello, thank you, Simone, and welcome everyone to this masterclass on federated learning. So, as Simone kind of laid out, we're exploring federated learning as an enabling technology because we work with organizations of all sizes. For many of these organizations, there's a barrier to adopting machine learning, which is data security and sharing data and getting the data necessary to build the relevant machine learning models that can solve their business problems. And so as an AI technology team, we set out to examine this problem and to kind of present a solution to industry. And there are two kind of parts of this. The main part is the development of a federated learning library, which I'll go into more detail later. But the key kind of thing to acknowledge at this point is that there are quite a few solutions out there for federated learning in terms of libraries from Google, looking at TensorFlow, PySift, but looking at all of these solutions and the kind of fragmentation in the market, we felt that for larger companies who want to adopt machine learning, they needed a platform where you could easily create a proof of concept application using federated learning and actually distribute it on devices, and give them the flexibility to choose their own machine learning frameworks. So we'll go on to explain about the library. And right now I'll take you through an end-to-end demonstration of federated learning, and kind of introduce you to the key concepts and talk about an example application that we developed using our federated learning library, and an open data source looking at a data set of plant leaf images. So looking at the agri-food, agribusiness sector, and the kind of specific application we'll be looking at is detecting diseases in crops. So I'll just start the demo now. So as I mentioned before, often when we talk to businesses, we see a lot of excitement about the potential of machine learning to solve their business problems. But we also see concern about whether people have to compromise on privacy and security of their data. So looking at the kind of the problem here, typically, as people know, especially if you're looking at quite complicated, difficult to solve problems, often with machine learning, you need a lot of data. And often one party doesn't have all the data necessary to build and train a machine learning model that is sufficiently powerful to solve that problem. Often they need to access data from multiple stakeholders that have different aspects of the problem in their data. And when you look at how conventional or centralized machine learning is done, often all the data is collected in one place. So in the case of a multi-stakeholder scenario, this would mean that multiple organizations or potentially multiple individuals need to pool their data in one place in order for a machine learning model to be trained on it. And this is often difficult for various reasons, including legal reasons, but also kind of business sensitivity and so on. So federated learning is a potential solution to this problem, and I'll walk through an example of what that of how it can help. So very simply, compared to centralized learning, what federated learning allows you to do is for each of the stakeholders or individuals, they can keep their sensitive data locally and not share it as part of the collaborative process of training a machine learning model. And then instead, what you do is the local models are trained on site or on device or within the silo, and then only the updates or the insights are shared centrally with a global model, which is then shared to everyone else for everyone's mutual benefit. But the data is kept secure and at the local site. So in short, federated learning enables businesses with a shared problem to collaboratively create an AI solution without sharing their sensitive data. So let's have a look at some examples of this already in action. So probably the most commonly kind of referred to example in federated learning is something that almost all of us use every day. So Google's Android Gboard and also Apple's iOS has this feature as well. Uses a text prediction algorithm which is trained using federated learning. So what that means is that on millions and millions of smartphones around the world, there is already a federated learning system that is learning from people's, for example, text messages in order to predict the right next word. But that sensitive data is never shared with the central server or central kind of infrastructure of, say, Google or Apple. And you can understand why this is a kind of crucial requirement for allowing people to kind of access a valuable feature, but also be confident that their data is not being shared. So this is what we would refer to as a cross-device federated learning scenario, where you have many thousands or even millions of devices, and that would be in our scenario the node or the worker that is doing that machine learning locally. We also have cross-silo examples, and this is kind of one of the most successful kind of projects to date. Something that's already that's still ongoing is the Melody project, led by Oken, an AI health company, working with NVIDIA and 10 of the biggest pharmaceutical companies to enable drug discovery using federated learning. And the key kind of message here, and something that we'll reinforce later, is that the kind of big step change in performance that they're hoping to deliver is enabled by essentially the sharing of data. It's not necessarily a major advance in the machine learning algorithm. It's simply that there are vast amounts of valuable data out there that can be used to solve a problem. But there is this, there are institutional, legal barriers to sharing the data directly. But what this enables is the sharing of drug discovery data, and the volume of data available in this project is increased by an order of magnitude, and that can have kind of great positive impacts for future drug discovery. So just to mention in terms of how we're using federated learning at the Digital Catapult at the moment, alongside the development of our federated learning library, we're part of a consortium called No Risk, which is looking at analyzing the risk in supply chains. And one aspect of this is looking at a certain type of document, which is distributed across a handful of companies, in this case insurers, and training a model that can identify particular risks in those documents or particular sentences, but without actually sharing those sensitive documents between those parties, but developing a model that can benefit all of them. So now that I've showed you a few examples that are kind of currently deployed and being developed, I'll take you through an example of applying federated learning step by step in an agribusiness scenario using real open source data and our federated learning library. So first of all, we're going to start with the problem and the user in this case. So it being agribusiness, we're going to start with Farmer John. So Farmer John grows tomatoes and apples, employs 30 people, enjoys apple pie, and worries about crop disease. And the problem here is that crop diseases are spoiling between 15 and 20% of Farmer John's crop every year. And of course, it's critical to catch these infections before they spread more widely. And while Farmer John is an expert at identifying crop diseases, he can't be in all places at all times to identify this. And the training and the expertise is not very well distributed among his employees. So what is a solution to this? Potentially, he could use machine learning to detect crop disease. So the next kind of question that comes to mind is, and what is the data that is needed for this kind of machine learning solution. And in this case, it is images, hundreds or even thousands of images of plant leaves, which are correctly labeled. So you might have a tomato leaf that is labeled as a healthy tomato leaf, or the leaf from an apple tree labeled as a apple tree leaf with rot. And you need many, many of these examples in order to train a high performance computer vision algorithm to correctly classify these leaves, so that once you deploy that on, say, a phone, then anyone is able to correctly identify a crop disease on a farm and then take action. And the domain knowledge is kind of critical for this. So this an important thing to realize, and I think many people who have worked machine learning problems before know that it's really important to look at the distribution of your data and think about what impact that might have on training machine learning models. So in the case of Farmer John's data, you can see there's quite a bit of imbalance between the different categories of crops. So, for example, here you can see we have quite a few green, healthy tomato leaf examples, quite a few diseased tomato leaf examples, but with apples, there's only a few of, say, apple scab or apple rot, few examples, and no examples whatsoever of strawberries, because at the moment, Farmer John does not grow strawberries, but he might want to do in the future. So this is what you describe as an uneven or imbalanced data distribution. And this might pose a problem for training a machine learning model, because a machine learning model needs a lot of examples of all the different categories that you care about, that you want to identify. And so it might be a challenge for training that model. And so when we trained a model to identify these classes on Farmer John's data set, we achieved a certain level of accuracy, in this case, 82%. But when we dig down into that and think about what this solution is supposed to do, we can see that obviously that is not good enough, because we care about identifying diseased plants. So if we test the model on a healthy plant, we see that, okay, so on this tomato leaf, we can correctly identify that this is a healthy tomato leaf. And this is not surprising in a way, because we know that we have many examples of this kind of leaf. But if we then test it on a diseased plant, we can see that it incorrectly identifies this apple leaf as healthy, when it's actually an apple rot leaf. And then we can go back to, well, why did this fail? And of course, it is an impactful failure, because that disease can spread throughout the crop, and the kind of the problem that this solution was designed to solve has continued. So the clear problem here is that Farmer John's dataset is not representative. There isn't enough data to train the model on how to identify the kind of key categories of interest, which are the diseased plants. So how might we improve that model? And it's a clear answer in many ways. There are, of course, other means where you can improve the machine learning model, but very often, all other things being equal, the more data you have and the more representative data you have, the better the results you can achieve for a particular application of machine learning. So luckily, there's a farming community or association where multiple farmers have the similar problem, and they're aware they need to share data, or they think they might need to share data in order to solve that problem. But they're worried about the potential sensitivity of that data. So let's explore how we'd apply federated learning to this problem. So here you can see that the data distribution of the different crops that they grow is of course different between different farmers, but if they're pooled together in a theoretical global data set, it's quite a representative, or much more representative global data set, which can be used to train a better machine learning model, but they don't want to share it directly. So how can they collaborate using federated learning? So at the very high level, and I'll kind of dive deep into this later on, but at the very high level, what happens is that there's a machine learning model which you can think of as a set of, for example, parameters in layers for a deep learning model that is initialized at the center. It is then sent out to the nodes or to the farmers, and at the local level, it's trained on their local data, local labeled images. It achieves a certain amount of accuracy, and then it's returned back to the center. And it's not the data or the images that are sent to the center, it's the updated model or set of parameters. And then this is done over many iterations. And this is how you achieve a higher level of accuracy, because you're sharing the kind of the insights and the improved models between multiple participants without sharing the data. So you're able to train a machine learning model on all the data without seeing it directly. So let's dive into kind of how federated learning works in more detail. So I'll just skip this slide because there's a lot of text, but I'll explain it on the next one. So in order to understand how federated learning works, we'll just kind of have a quick primer on how it would work locally. So in this case, we're training a deep learning model, a computer vision model on a data set of healthy and diseased plants. And typically what's done is you divide the data set into batches, say 16 images or labeled images. And then those images go through the network, and certain predictions are made based on the parameters of that network. And then you compare the predictions to the true label. And then you get an error message or an error signal, which can then be pushed back through the network and correct some of those parameters to improve the accuracy. So this is a typical kind of pattern of training any neural network, and it's done in batches. So if we think about how this might be done in a distributed way, the way that it kind of starts off is you randomly initialize the parameters of your network at a central location, and then those empty models or random models are sent out to each local node. And then if we zoom into one of those nodes, you do the local training process that I just described, in which we're using that local label data set to train the machine learning model, to train the parameters in order to minimize the error and increase the performance. And this happens at each of those local nodes to achieve a certain level of performance with that particular batch, for example. So now you have slightly better models, but slightly different models at each local node. And then those local models, but not the data, is shared with a central server and aggregated in some way. So there are a number of ways you could do this, but the simplest way in this example is just to take each of the parameters from each of the models and just take the average. So you're kind of averaging the insights from each of the local models, and the result is a model that is integrating elements or insights from each of those models and achieves a higher level performance. So 42% in this case. And then what happens is once you have that kind of global model trained centrally, it can then be distributed back to the local nodes. It's then trained again to achieve a slight increment in performance, and then return to the center, and the iterations continues until you reach your satisfactory level of performance. So our federated learning system in action, everything that I just described, essentially the kind of communication between the workers, the training on each of the local workers, and then the aggregation of those models at the central server. This is all built into our federated learning library, and we've built it in such a way where you can use any machine learning framework. So for example, PyTorch or TensorFlow. And what we've done is we're going to make sure that it's platform and framework agnostic and satisfies many of the business requirements of a library of this type. So for example, kind of authentication, encrypted communication, and scalability. So let's look at why we would do this in the first place. And very simply, as we've kind of laid out before, if you try and train this model on a limited data set that is not representative, you shouldn't be surprised that the performance you get is be relatively inferior to the performance you would get if you had more representative data. So if you can see the numbers there, this is based on real data and is not surprising in the least, because it's essentially comparing the model trained on a portion of data to the model trained on a larger and more representative data set. So in short, federated learning is not magic. It's an approach that enables the training of a machine learning model on a larger and usually more representative data set than otherwise would have been possible due to privacy and security concerns. And in our experience working with businesses of all types, we understand these are critical barriers, and this is why federated learning we see as a key kind of enabling technology. So let's go back to the example that was failed by the local model. So using this this global model is trained on a more representative data set, you can see that the apple rot example has been correctly identified, and in this case, Farmer John would be able to take action and to solve his business problem. And so in summary, the benefits of using federated learning is that you will get a more accurate machine learning model because you have a more representative data set, and sensitive local data is still kept private. And going back to some of the examples, there are a number of different kind of application areas of federated learning. It's a general purpose technology. So we have the examples of how it preserves user privacy with Google Gboard, preserves sensitive data in kind of medical research applications. It also has other kind of periphery benefits. For example, if you're looking at a autonomous driving example, where a lot of data is gathered by onboard sensors and cameras, that's a significant amount of data that you would need to send to a central location for further training in order to improve autonomous vehicles. But if you're doing the machine learning locally on the car, then you only need to send the updates to the central location, and that saves on bandwidth, and it also has privacy benefits as well. So just to kind of finish up on talking about business models for federated learning. So as you might be able to, as you might have kind of realized, a lot of the work that will go into making a federated learning project work will involve kind of the organizational elements and collaborating between businesses. And that's something that the Digital Catapult is very interested in facilitating and thinking about kind of the new business models that federated learning will enable. So with that, I think I'm going to just switch back over to the slides. And I'll talk a little bit more about our federated learning library before I open up for Q&A. So the federated learning library is designed for industrial proof of concepts. And as I mentioned before, the key features include the ability to do truly distributed deployments. And this is something we struggle to find on existing libraries, because if you wanted to test the library on 100 Raspberry Pis or a consortium of 20 companies, many frameworks out there are mainly geared towards simulation on a local device and don't have the infrastructure to support this truly distributed capability. Of course, many companies who are applying federated learning have developed their own solutions, but are not necessarily open for experimentation. And because we want to use this library with business, we know that we need to solve problems like making sure there's secure authentication, encrypted communication, and its scalability and it's a scalable library as well. And because it's not a one-size-fits-all solution, it's framework agnostic as well, so you can use your existing TensorFlow, PyTorch solution and integrate it with the federated library. And yeah, so with that, I'll switch over to Q&A, and yeah, happy to answer any questions about this or about the Digital Catapult, and Simone can also assist me with that. Thank you. Well, I think you're on mute, Simone.
Oh, thank you. Thanks, Nathan. That was a wonderful demo. To our attendees, I urge you to post and upvote on questions. We have one question here, Nathan. First of all, giving you kudos for a great presentation. And the question is, do the partners and individuals that need to use the same, do they need to use the same data acquisition approaches to create the same formats? Or does this allow for flexibility? How tricky is it in practice?
Yeah, so it's a great question. So, so when I was introducing a demo, a key kind of caveat there is that this is designed to help businesses or to help people with a shared problem. So the problem needs to be similar essentially, and the data does also need to be similar. So what I would say is that the data acquisition piece might be different. So it could be a number of companies that acquire data through, maybe a variety of sensors, or so it's what can be done in terms of flexibility is that no matter where you get the data, it needs to be addressing the same entity. It needs to be about the same problem. And then even if you have variability about how the data is collected, there can be various pre-processing steps that can get everyone's data to the same format and the same level, more or less. Now, obviously, there's a lot of kind of complexity in that, and it would depend. The ideal scenario is everyone has, say, the same device, or same, for example, in manufacturing, the same kind of machine. But they can't share data. The data from that machine is identical, so it's ready for Federated Learning straight away if you want to use that data. Now, it is possible to have data sources that vary somewhat, and you could get it closer through some pre-processing steps. But it would have to depend on the case. So as similar as possible, but it is possible for there to be some flexibility. That's my answer.
Thank you. And what about the size of the models to exchange between the central node and the local nodes? This induces a lot of traffic. So does model size have an impact?
Yeah, it can do. I would say that it would obviously depend on the specific use case, but there are a number of things that can mitigate this. So, for example, even if it is a large model, there are a number of ways where you could compress the model in conventional ways. So for communication, just using conventional file compression. You could also use use an approach to compress the weights as well, to achieve something that is of a similar performance, but it takes up much less data. So there's that approach. Also, you have to consider potentially how often are you exchanging the machine learning models? If you're thinking about cross-silo situation, it might be that you update the global model once per day or once per week, in which case it's less of a barrier. And also that you could have a solution where everything is in a protected cloud environment, and actually all the data is kind of co-located in terms of cloud, but is securely cordoned off. So actually, it could be extremely quick to access someone else's model because it's in the same, for example, cloud infrastructure or cloud site, but it is securely portioned off. So it's not necessarily that you have to upload the entire model from a local site into the cloud every time. That's one option, but there are other options.
Okay, thank you for that. Which interoperable format for the model exchange are you using for the library?
So in terms of how the library is designed, you've separated out the different layers. So you're able to define, for example, what machine learning framework you're using locally, and then how those models are aggregated at the center in terms of how it's exchanged. And that is one of the things that is common among any federated learning system, which essentially you would be exchanging binary strings and some metadata about the update, and that would not depend on what kind of model it is, and that's what's exchanged between the model, the local node and the server.
Thank you. And finally, in terms of questions, how do people get access to the library to build their own POC?
So, I'd say the best way is just to get in touch with us, and we can have a conversation about the use of the library. We are considering potentially kind of making it kind of more widely available, but that's under discussion at the moment. But yeah, please do get in touch if you want to discuss more about the library.
Okay. Final call for questions on the demo and any other federated learning or digital catapult related questions anyone may have. If nothing is posted, we'll switch straight into the panel introductions and the moderated panel discussion. Okay, let's transition to the panel.
Okay, thank you, Simone.
Thank you, Nathan. Hi, everyone. Hopefully you found that quite useful, and thank you for posting your comments. So to kick off the panel, let's start off by formally introducing everyone. I mentioned them earlier, but formal introductions are going to be provided. So first up, we have Sid Kalita, the Data Innovation Lead from the Food Standards Agency. If you can introduce yourself and give a bit of background.
Thank you, Simone. Good morning, everyone. I am Sid Kalita, and I lead on data innovation at the Food Standards Agency. For those of you that aren't familiar with the work of the Food Standards Agency, or the FSA, as we're known, we're a non-ministerial department working across England, Wales, and Northern Ireland, ensuring that food is safe for consumption and is what it says it is. Provenance of supply chains is a big area of interest for us, and we've trialed a couple of projects using distributed technologies, working in collaboration with industry, and are also starting to use artificial intelligence and machine learning to predict food risks, mainly using open data at this stage. We're also involved in work to identify governance models and standards for distributed systems, and are interested in the opportunities that federated learning might offer to the food supply chain to complement some of the work that we're doing. Thank you.
Okay. Next, we have Naman Tamuz, the Chief Product Officer of BitFount.
Hi, hello everyone. The pleasure to be here. I'm Naman. As Simone mentioned, I'm the Chief Product Officer at BitFount. So I'm a physicist by training, and I got into the startup world about 8 years ago via data science, a couple of years, and then quickly realizing that product management and product strategy were the things I really loved. Prior to joining BitFount, which is quite an early stage startup, which I joined a few months ago, I served for a few years as the CPO at a B2B SaaS company called Judil, which specializes in aggregating and connecting up data sets to form a kind of knowledge graph for the entire economy, specializing on SMEs, privately held SMEs, so companies that make up 99% of the companies which exist. It was in that role that I got exposed to the challenges of aggregating lots of data sets, but also building machine learning models about them, evaluating those data sets in the first place, but also assembling large enough training sets for the models we wanted to develop. That took up tons of manual work for things which have been done thousands of times around the world and which weren't particularly proprietary types of information. So that's what kind of got me really excited about BitFount when I met the founder a few months ago. So BitFount was founded recently by a great guy called Blaise, who previously ran Apple's engineering office in Cambridge here in the UK and was chief architect for Siri, part of Siri Understanding at Apple. What we're doing at BitFount is we're building a kind of marketplace to enable companies or groups of companies, as kind of Nathan described earlier, to easily get up and running with adopting a variety of these kind of privacy enhancing, they're called kind of analysis tools, of which federated learning is one. In contrast to a lot of the companies who are developing kind of developer tools and libraries, we're building a very user-friendly platform marketplace to make it very easy for projects to get started and kind of harness all the power of these methods which exist. So looking forward to the discussion. As you've probably got a sense already, there's a lot of detail around different applications of this technology. So obviously, if anyone's interested in exploring one of these projects or discussing a problem they're facing whose solution they suspect might be accelerated by one of these methods, definitely don't hesitate to get in touch after the session. Thanks.
Thank you, Naman. And last but certainly not least, we have Jonathan Pumbach, the Director of the Centralized AI at Consensus Health.
Hi, everyone. Pleasure to be here. I work for Consensus Health. We are a spin-off of a bigger company called Consensus AG, which is the largest pure play company in the Ethereum space, a company focusing on blockchain. At Consensus Health, we are very interested in combining decentralization technologies and the potential they have for traceability, creating new marketplaces and economies with privacy enhancing technologies. One of which is Federated Learning. It's something we're exploring for our product, but we're also very interested in the various forms of trusted execution environments, homomorphic encryption, and zero knowledge proofs. So that's the kind of space we're evolving in, and all these things are applied to the healthcare vertical. That's our specialty. From a personal point of view, I've been spending the last few years at Imperial College London in a group working on medical image analysis, and that's actually how I became familiar with privacy enhancing technologies. I got frustrated by the difficulty we had in sharing sensitive data even amongst academic institutions, and I became aware of a community, a growing community called Open Mind, which is one of the leading community working with Federated Learning and other privacy preserving machine learning tools. And I thought that was one of the best answer to avoiding all the troubles we had with data sharing while still enabling collaborations among multiple institutions. So yeah, that's my story.
Thank you, Jonathan, and thank you all. And again, don't forget to post your questions in the Q&A box. So let's kick off with a more, I guess, general question. So in your point of view, panelists, what are the current limitations, challenges, and bottlenecks in federated learning? Any takers? How about you, Naman?
So first of all, I should say from a technical perspective, my impression is that for a variety of use cases, the kind of techniques, broadly speaking, as outlined by Nathan, are quite well understood. So, and obviously, and if the panelists kind of jump in if I'm misrepresenting it there, there's no, the techniques that Jonathan mentioned, differential privacy, federated learning, these are all ready to be rolled out. There are issues around that come up that I think some of the Q&A was alluding to around when you're dealing with decentralized data sets, you have to think about the distributions, the statistical distributions of the data across those different data sets and how they might vary from each other. So when you're normalizing the data, how do you do that in an intelligent way that needs to kind of take into account what's happening at each data set? So there is still kind of various kind of protocols being proposed to compensate for that, because it's known that if you just arbitrarily assume identical distributions across the data sets, your model isn't going to be as effective as it would otherwise be, obviously, in a centralized model. So that's one kind of obvious limitation. There are practical limitations around specific. This happens to be one that we've explored, so I'll mention it in case it's an interesting particular use case. So this is, by way of context, federated learning comes in two flavors that are often referred to as horizontal and vertical, where horizontal machine learning refers to conceptually think about it as kind of adding rows, adding records. So similar to what Nathan demonstrated. So you're seeing more samples from the real world, but of the same schema, same type of columns. You're improving your training set that way. And whereas vertical federated learning refers to the addition of the joining of additional features onto your data set. Those two techniques incur very different technical processes, and specifically in the context of vertical federated learning, there are still a lot of questions about how to do that in an efficient way. So that again will depend on, in terms of, because it requires more data, the data communication overhead. In a nutshell, there's various ways they require data communication. So that incurs both the question about, oh, if you're sharing actually some form of information between the different participants, how what does that mean, and how well is that encrypted? But also the data overhead. So again, depends on the context. Nathan mentioned some mitigating factors and so on. So those are kind of technical limitations, as it were, and challenges. Obviously, there are other organizational and legal ones, but that's just
I'd like to piggyback on Naaman's point, actually, on your first point on the data heterogeneity. From even like from a more pragmatic point of view, you've even got, is the data captured in a standard way at all the sites that you're dealing with? And I mean, we see it a lot in the healthcare community. I mean, there are standards like the FHIR standards, for example, that try to tackle these kind of challenges. But actually, when you think about it, it goes even further, because even data captured in the same way can vary in the way they've been captured by the operators. So you can have like these multiple levels of discrepancy in the data that, of course, in the ideal setting of the academic studies, you don't really see. But in the real world, that's the kind of things you are facing with. And I think the best answer we have to that at the moment is to jointly design your system with the customers, with the collaborators you're working with, or if you're lucky enough, like Google, to be able to control the whole stack end to end, from the application that collects the data to the model that exploits them, and the federated learning architecture that uses it, then it's of course much easier for you to set it the way you want.
Yeah, I'd agree with both what Jonathan and Naaman has said, and just building on that as well. I think what then starts to become really interesting is the governance and ownership of those centralized models, and the perceived sensitivities around sharing parameters, particularly those that are commercially sensitive or would enable us to somehow identify back to those contributing parties. The other thing that might be quite interesting to look at is, even if there's a subset of models to choose from that are pushed out to the local nodes, if they're seen to be slightly prescriptive, then that might follow a certain taxonomy, which could be good, but it might increase the barriers to entry for organizations that have built extensive business processes, say on a different taxonomy. And then, the bit that we sometimes tackle in government is around the cultural barriers to information sharing, which is quite interesting and hard to quantify, I think. And although you're not moving raw footprints of data here, which is really good, there's still a bit of convincing and messaging that we need to do as a collective, I guess, with the various stakeholders around.
Absolutely.
Yeah,
absolutely. I think it's a matter of what's at stake, what are the incentives, and that's something that you see extremely clearly in the example that Nathan brought up during the presentation, the Melody Consortium in the pharma industry. It's actually quite impressive to see that they've been able to put together 10 pharma companies that would be natural competitors to each other, to collaborate on jointly training a data. So it means that they have each of these 10 entities have considered that the value in sharing, in a way, the data that they had and contributing the data to the network was higher than keeping the data siloed for themselves and exploiting them themselves. But you can see the other side of the coin as well. There's only 10 pharma companies, and surely there's much more than that, and much bigger ones that are missing in Melody. So why is that? Did they consider that their data was more valuable in a way than the sum of all the other 10 parties? So I think that's one thing that's very important. And as you said, Sid, like it's about talking through it. But I kind of hope that in the future we'll be seeing like the emergence of more autonomous marketplaces where these incentives are basically driven by the market itself, and you'll be able to decide whether or not it's worth for you contributing to a specific network.
So just since this was quite a pessimistic type question, and Jonathan's last the point that triggered a thought, which is kind of very top of mind for us at BitFound, that I thought might be worth sharing in the context of this question. But Simon, cut me off if it's too tangential. From a kind of very pragmatic point of view, there are all these question marks which might exist. Is the data distributed this way? Is it valuable? Does it add anything? New features? No. Is it worth the effort? So, can we wrap it up in trying to understand? A party will be trying to understand the ROI, the return on their investment, either in participating as a data provider or in utilizing this external data set in some way. This is through the lens of BitFount as a kind of marketplace, for example. One of the nice things that we like about federated learning is that it offers up the ability to, because you're sending out models and you can assess the performance of the model, there's actually a product offering that we're exploring around letting someone understand the boost to the performance of their model that the data set would provide them were they to make use of it. And you can actually do that without, by regulating kind of this process, you can do it in a way that protects the commercial interests, both of the data provider and of the model builder. So you don't share them, the data provider doesn't get the model that the model builder built. But likewise, the model builder can understand, oh, this data set, from a purely pragmatic perspective, heuristically regard, if it has it improved my predictive power, the predictive power of my model. And that can guide them in a privacy preserving way, whereas in the past, you'd have to share all the data, run all the model. So commercially, it's interesting to think about these things. I think often the discussion goes around like collaborations and purely all aligned incentives, but like Jonathan mentioned, the marketplace. So it's kind of, I think these things will evolve, and the understanding of how different data participants get compensated for their data will also, for participating, will also evolve. So there's, lots of interesting dynamics. Yeah.
Well, that's a brilliant segue in terms of ROI or indicative ROI. Have any of you come across any tangible use cases that could be applied and quantified to justify the return on investment for federated learning?
I'm happy to jump in. I think the food supply chain is one that's particularly interesting because it's characterized by multiple organizations, and what would be really useful and interesting is to move beyond the one up and one down view of the supply chain that currently exists, and that could dramatically improve provenance and traceability. The other thing that would be quite interesting is around the corroboration by reusing information, so that you could create an ecosystem of trust, as the example that Nathan demonstrated shows. And that could lead to visible supply chains, which will enable the understanding of pressure points in the system. So that's quite appealing for us in terms of predicting or better handling some of these black swan type events that we're seeing at the moment with COVID pressures on the supply chain, where you've got multiple collaborating parties working together without necessarily having to deal with the traditional problems of sharing data, who's using the data, and where it's stored, etc.
I think from an individual point of view as well, it changes the way you think about the value of your data, because at the moment the only way you have to do it is you can contribute your data to a study, for example, and you can even be compensated for that. But what you're doing by doing so is creating a copy of your data, and in terms of in economics points, it's you're duplicating the data, so you're naturally lowering its value. Whereas techniques such as federated learning and other privacy enhancing technologies allow you to introduce a form of digital scarcity in the data, because you only keep one single copy of the data for the whole lifetime of it, and you're the only one or a group of persons that decide on what to do with it. And by doing so, you shift from a paradigm of data sharing for money to data lending, in a way where you can repeat this process over and over again. If you have tools like Naaman was describing, where you are quickly able to assess whether a specific piece of data, a whole data set, will add, and how much it will add to the predictive power of a model, then that all comes together.
I guess for my part, in terms of like concretely putting numbers against investments, the only framework I can think of is just to take all the work that gets done on a regular basis to try and understand the return on investment of machine learning in general, even the kind of introduction page for this, the website for this event was, mentioned the whatever it was, $4 trillion of anticipated business value to be created from that people are hoping would be created by 2022 or something like that from AI and machine learning, and to contrast that with the stories we hear around difficulties in bringing it to adoption, or the number of use cases that are actually facilitated and can make it through into production. So I think of federated learning, when we're assessing use cases for our platform, we think about specific use cases, what's the size of that market, and then how much is unlocked by this particular contribution to the productionization of machine learning. So you can come up with a fraction. You can say, okay, there's these 20 use cases, they're collectively projected to be worth X billion, and if federated learning can reasonably be expected to speed this one up by 20%, this one up by 50%, this one up by 2%, you can get a number that way. But essentially, it's linked to the value that people get from machine learning.
Okay, thank you. A question from the audience: how do generative models such as autoencoders and GANs preserve the security and privacy of data? Are they applicable to federated learning? Any thoughts on that?
So I'm not an expert by any means on autoencoders and generative models in general, but if the question is around to what extent does the output of an autoencoder represent a private kind of anonymized version of the data, I don't know if that's the context, but I think that it's kind of still the details of that are still unknown, and to what extent things are considered completely anonymous or not. Nathan mentioned earlier techniques that well, he mentioned compression actually, but there are, I guess it's also worth mentioning that in the wild, federated learning is usually combined with one or more other techniques to enhance privacy, depending on which guarantees the stakeholders want. Even shuttling model parameters around could be considered non-secure for some participants, in the sense that it compromises some kind of commercially sensitive information. So techniques like differential privacy and homomorphic encryption, and also hardware solutions, I think Jonathan also mentioned these, but also secure enclaves, which are essentially chips in which you get a formal guarantee that no eavesdropping took place on the processing of the data that was in them. All these can be combined to provide different levels of comfort to different stakeholders. So there's no one size fits all answer, but I don't off the bat see anything about generative models which falls outside the otherwise quite still broad range of possible guarantees you can provide. Yeah.
You do see them used in attempts to implement attacks against federated learning networks from an orthogonal point of view, where basically the GAN is used to try to reconstruct the original data using the updates, the model updates that are transmitted across the network. So of course that's like considering some very specific settings underneath, but yeah, that's one other application we've seen of GANs in this kind of federated learning networks.
Thank you for that. I had just cut out a bit while you were talking, Naman, but I am back. Are there any GDPR implications with federated learning? If so, what are they?
So I can start on this because we've spent some time on quite a lot of time on this recently. There's short answers and long answers. So the short answer is that it's still being worked out, and both the EU and the Information Commissioner's Office in the UK are still coming to terms with what federated learning means. It's not fully aligned with the mental model they had in mind of when they were defining controllers and processors in the original legislation. So there's a lot of I think hopefully increasing amount of thought being put into what exactly is happening here. One example of that I can give from kind of in terms of legislation, recent things are a set of guidelines that the EU put out in July of this year. The call for submissions on them was just on Monday, and we submitted our feedback on that, clarifying the roles of controllers and processors. So the slightly longer answer is it depends on the details of the scenario in which the federated learning is being run. Just to give a flavor of it, original GDPR talks about a data controller as someone who determines the purpose and means of the processing of the data. So those two words are, well, actually three, actually determining and the purpose and the means. And you have to kind of dissect each of those to understand who counts as what. And actually in these new guidelines, the EU goes a bit further, actually, and also if you look at some precedents recently at the European Court of Justice, goes a bit further, and actually we've seen examples where someone has been a controller even when they haven't strictly held the data with them. So in the sense that they have not, it's basically extending the definition to beyond just determining, like being the sole person who can actually control this data because they hold it. If you are seen to very significantly influence the purpose and means of the data processing, you may still be considered a controller. And so you can imagine in different federated learning settings, different participants may be assigned different statuses. And there is also a legal status type of controller under GDPR called the joint controller, whereby two parties are seen to significantly influence or determine the means and purpose of the data processing. So again, depending on the scenario, there are situations in which, in the federated learning system, different data contributors could be considered joint controllers of the data for the duration of the processing. So there's all sorts of questions there as well. If it's because the data isn't actually moving, are they considered joint controllers just for the however long it takes to train the model, and then after that process is finished, then they're no longer jointly liable for the data, which kind of makes sense because the resulting output is a completely anonymous model. So that introduces a new type of thinking from GDPR's perspective of this joint controllership being very temporary. Also, what's the role of the intermediary, the central hub? If it's a third-party platform like BitFount, what's our role in this? In certain scenarios, we'll just be shuttling instructions, so we might not even be a processor in the sense that we won't ever touch any sensitive information, even if it is in principle being operated on different parts of the network. Or in the case of vertical federated learning that I touched on earlier, where you're joining data sets that do require some shunting around of actual even encrypted parts of the data, everyone might be a joint controller. So it's quite it's a subject that's quite in flux, yeah, look to the EU for some guidelines if there's soon. Yeah,
I think the encryption part is important, and especially when used in collaboration with federated learning. There's been a few works by the United Nations and other Horizon 2020 projects as well that have basically evaluated the impact of using a secure multi-party computation, so a cryptography technique that allows you to compute data while they remain encrypted in alignment with GDPR. And basically the conclusions of these studies are that since the process of SMPC splits the data into shards that are not re-identifiable by themselves, they are not considered, these partitions of the data are not considered personal data anymore. And as such, they do not fall under the scope of GDPR anymore. So it seems that techniques previously enhancing technologies such as SMPC in a way allow you to comply with GDPR in maybe a smoother way than you'd have to.
Yeah, I think that's a really interesting and useful point in terms of using methodologies such as SNPC. The slightly changing the direction of travel. The other one that we're quite interested in is Article 22, which is the data subject shall have the right not to be subject to a decision based solely on automated processing. So whatever the ultimate architecture is of the system, it would be quite useful to see that it doesn't take away that human element in that architecture in terms of the final decision making. The other thing that we find quite interesting, particularly when looking at the supply chain, is the visibility of those participants. So in the example that Nathan very kindly shared, you've got the ecosystem of farmers, if you like, contributing that insight around crop rot, if you like. But those are the primary participants in that ecosystem. What might happen if you've got n number of participants, as is quite typical in a supply chain, is that you might have indirect participants that are contributing to those primary participants. And they might be, depending on their level of data literacy, also from an ethical point of view, quite interested to know how their contributions are being used in terms of that centralized model. So going back to Naman's point, I think, I know it's a get out of jail type answer from me, but it really does depend on the type of circumstances and the ecosystem that you're working with.
Indeed.
Yeah.
Yep. Thank you.
I'll just take this second to point out that there was a response on the generative models in the chat, with someone mentioning that GANs are very suitable architectures to work with differential privacy methods. They are effective at protecting the privacy of the original data, and that's unchanged by the Federated Learning framework. So, yeah.
What are the typical must-haves in terms of foundational elements and enablers for organizations that want to implement federated learning? So, for example, when I talk to industry in my role at the Catapult, it's very much fundamentals around data, the importance of good data and having enough data. If an organization wanted to move that conversation on to actually implementing federated learning as part of a model, what are the foundational enablers that are critical to achieve that goal?
Don't you need the toolkit from Digital Catapult?
Yes, indeed.
Yeah.
Do you foresee any institutional? Go on, Naman.
No, sorry, I wasn't going to make a profound contribution. I was just going to say that the same similar enablers as you would need for a successful machine learning project. You need the skills, and I think increasingly importantly, I think you need the buy-in. Like, this is one new technique. It's not like the world has fully, we've bottomed out the value that we can get from non-federated learning, and now there's this new thing which is like, oh, obviously that's everyone has to look to it. This is another innovation on the heels of a lot of innovations, and so I think a lot of it increasingly comes down to leadership buy-in and understanding of the exploratory nature of machine learning in general, and so on. So and I think it's on us, the people who are kind of building hopefully the foundations for this whole federated ecosystem, to reduce the barriers as much as possible and make that explainable in clear terms to the business kind of decision makers, whoever they may be.
Absolutely, because I think we're still in a very nascent field, and in terms of like the maturity of the tools, we're absolutely not at what you can expect from the regular data science stack.
Yeah.
And this is because it's still quite early in there, but also because it's extremely challenging, mixing very different fields: machine learning, distributed computing, cryptography. And it's pretty hard to put together this kind of expertise in a single team and in a single framework. So I think that's why like this kind of initiative like yours, putting together this framework would be extremely valuable, and especially if you design it with practical use cases and actual engagement with the business world in mind, that would be extremely valuable to the community, I think.
Yeah, and just to add to that as well.
And demystifying.
Yeah, absolutely. And I think the other thing that, building on Naman's point around demystifying, it's quite important that this is as simple as possible for those consuming this service to make use of it, because as someone said, you don't need to understand HTTP to use the internet, for example, and that's how it should be for most businesses using this methodology. The other thing that would be, probably a prerequisite in my mind is looking at some of the taxonomies and models for interoperability and standards. For example, looking at food products, how do you describe the food product as it moves across the supply chain? Are we talking about the same thing? So is it an apple you're describing, or is it apple pie further down the chain? And there's various food codes already published by various organizations. So it'll depend on doing a bit of mapping, I think, as Nathan already alluded to it during his demo.
Yeah. Any other points to add on that point? I think demystification and stakeholder management is an interesting one, because we often find that industry, especially the industries that we deal with, they see AI very much as that special magic pixie dust that will solve problems. And once you start really digging down into why and do you have the enablers, it's oftentimes become a blocker. And I think your point, Sid, on making it as simple as possible and as easy as HTTPS, you don't have to teach people that goes a long way. There's an education piece that we always have to do to bring people along on the AI front. That's sometimes harder than some of the other technologies that we implement as a catapult for IoT, from an IoT perspective, and how that's consumerized and all the gadgets and tech that we use and interact with on a daily basis. So that's something we're working on, and we hope with the Federated Learning Library, we can continue to make it as simple as possible and as easy as possible for business stakeholders to understand what it is, the benefits and the potential ROI, because at the end of the day, that's also what they're interested in. Right. Do you foresee, and this might be a tough question, but do you foresee any institutional or legal barriers to adopting federated learning across different organizations? And if so, what can we do to tackle those challenges?
I think, sorry, Naman, go ahead.
No, go ahead. Yeah. After you.
Oh, sorry. I was just going to say, I think because how big data was made into this, big thing, forgive me for that comparison, but it needs a bit of a mindset change that you don't need reams and reams of raw data to come up with the same sort of inferences. So it'll need that mindset change again, I think. The other challenge will be around organizations that already have a commitment to existing legacy infrastructure. So convincing them that this can fit in and coexist with what they've already got, rather than requiring wholesale expensive changes to the infrastructure, will be quite useful, I think.
Yeah, 100%. On the legal front, the GDPR questions that we touched on earlier, I think, are still to be seen. So I foresee those as putting interesting parameters around what's possible with certain types of data. Yeah, it's probably interesting to look actually to the Melody collaboration to understand how they've approached that from a legal framework perspective. It's
I think
very large company.
To have more and more legal-minded people on these kind of panels to have the expert point of view. I would really love to engage with experts in this spectrum to understand better and
what the implications are. Okay, I think we will start wrapping up at this point. So thank you everyone for attending and submitting your questions. And thank you for our esteemed panelists for dedicating time out of your day to not only present your thoughts on federated learning, but also talk through some of the cool and interesting and exciting work you're doing to progress data sharing and data innovation within the UK. In terms of next steps, everyone that's registered will receive a copy of the slides that we went through today and further information on how to contact us or the panelists at Digital Catapult if you want to discuss more about how we can collaborate together. And on that note, thank you, everyone.
thank you very much.